Welcome to our channel. Today, we're diving into the realm of imagination and innovation, a place where the lines between science fiction and reality blur. We're talking about the future of programming, the tools that might one day shape our world in ways we can only dream of right now. We're exploring the top 5 futuristic programming languages that, if they existed, could revolutionize our world in ways we can't even fully comprehend yet. These aren't your everyday Python or JavaScript frameworks. We're talking about languages that could break down the barriers between human thought and digital execution. Languages that could optimize themselves and even think for themselves. Get ready to have your mind blown, because some of these concepts might sound like they're straight out of a sci-fi movie. But that's the beauty of technology, right? It constantly pushes the boundaries of what we think is possible. Imagine a world where the keyboard and mouse become relics of the past, where the act of writing code is as natural as thinking. That's the promise of thought code, a language so intuitively designed, so deeply integrated with the human mind, that it could translate your thoughts directly into digital instructions. Think about the possibilities. No more syntax errors, no more debugging marathons. With thought code, the barrier between your imagination and the digital world would simply melt away. You could create complex algorithms, design stunning visuals, or develop groundbreaking AI, all with the power of your mind. But how would it actually work? Well, we're venturing into the territory of brain-computer interfaces, devices that can interpret neural activity and translate it into digital signals. Imagine a sleek, non-invasive headset that could read your brain waves, identifying the specific patterns associated with coding concepts, logic flows, and even creative sparks. With thought code, these raw neural signals would be transformed into elegant, efficient code. The learning curve for programming would be practically non-existent. Children could become coding prodigies, effortlessly bringing their digital creations to life. People who never thought they could code could suddenly tap into the power of this technology. The applications of thought code would be limitless. Imagine architects designing buildings with a wave of their hand, musicians composing symphonies just by thinking about the melodies, or scientists running complex simulations entirely within their minds. Of course, thought code also raises some profound ethical questions. How do we ensure the security and privacy of our thoughts in a world where our minds are directly connected to the digital realm? How do we prevent malicious actors from exploiting this technology? These are challenges that we'd need to address carefully, but the potential benefits of thought code are simply too great to ignore. It could unlock a new era of human creativity and innovation, allowing us to interact with technology in ways we never thought possible. In the ever-evolving landscape of technology, one thing remains constant: the relentless pursuit of performance. We crave faster processing speeds, smoother graphics, and seamless experiences across all our devices. And that's where OmniOptimize comes in, a programming language so adaptable, so intelligent, that it could revolutionize the way software interacts with hardware. Imagine writing code once and having it run flawlessly on any device, from a low-power smartwatch to a high-end gaming PC. OmniOptimize would analyze the hardware, optimizing the code in real time to squeeze every ounce of performance out of the system. No more compatibility issues, no more frustrating lag. OmniOptimize acts as a universal translator, ensuring peak efficiency across devices. This would be a game changer for developers, freeing them from platform-specific constraints. Imagine developing a game or app that runs flawlessly on any device, without tedious porting. The benefits of OmniOptimize extend far beyond just convenience. Imagine the energy savings if our devices could run software more efficiently. We could reduce our reliance on batteries, minimize electronic waste, and create a more sustainable technological ecosystem. The world of programming has its own language, a complex tapestry of syntax, logic, and algorithms. But what if we could break down these barriers, making coding accessible to anyone, regardless of their native tongue or technical background? That's the ambitious goal of Babel Code, a language designed to understand and translate any human language into code. Imagine a world where you could write code in your native language, whether it's Spanish, Mandarin, Arabic, or any of the thousands of languages spoken around the globe. Babel Code would act as a universal translator, seamlessly converting your instructions into executable code. This would be a game changer for education, opening up the world of programming to billions of people who were previously excluded due to language barriers. Imagine classrooms around the world filled with students learning to code in their own languages, expressing their creativity, and developing the skills they need to thrive in the digital age. Babel code would also foster greater collaboration and innovation in the tech industry. Imagine developers from different countries, speaking different languages, being able to seamlessly collaborate on projects, sharing ideas, and building groundbreaking software together. But Babel code goes beyond just translation. It's about understanding the intent behind the words, the nuances of human language, and the context in which code is being written. It would be able to differentiate between subtle shades of meaning, ensuring that the generated code accurately reflects the programmer's intentions. This level of linguistic sophistication would require breakthroughs in natural language processing and machine learning. Babel code would need to be trained on massive data sets of code and human language, constantly learning and evolving to improve its accuracy and fluency. The development of Babel code would be a monumental undertaking, but the potential rewards are immeasurable. It could democratize access to technology, empower billions of people around the world, and usher in a new era of global collaboration and innovation. We've all been there. You're working on a project, the deadline is looming, and suddenly, your code throws a cryptic error message. You spend hours tracking down the source of the problem, only to discover a tiny typo or a misplaced semicolon. Bugs are the bane of every programmer's existence, but what if there was a language that could predict and prevent them? Enter Bug Shield, a revolutionary programming language that promises to make software glitches a thing of the past. Imagine a language so intelligent it could analyze your code in real time, identifying potential errors before they manifest. Bug Shield would be like having a superpowered debugger built directly into the language itself. It would constantly scan your code for logical inconsistencies, syntax errors, and potential security flaws, providing instant feedback. Imagine a world where software updates are deployed without a single bug, and critical systems operate flawlessly. Bug Shield could revolutionize industries like healthcare, finance, and transportation, where even the smallest software glitch can have catastrophic consequences. It could usher in a new era of software reliability, security, and innovation, freeing up developers to focus on creating amazing experiences. In the realm of science fiction, artificial intelligence often takes the form of self-aware machines, capable of independent thought and action. While we're not quite there yet, the concept of self-evolve, a programming language that can learn, adapt, and improve itself over time, offers a tantalizing glimpse into the future of coding. Imagine a language that doesn't just execute your instructions, but actively learns from them, identifying patterns, optimizing algorithms, and even generating new code based on the tasks you throw at it. Self-evolve would be like having a coding partner that constantly learns and grows alongside you, becoming more powerful and efficient with each passing project. The key to self-evolve lies in its ability to analyze its own performance, identifying areas for improvement, and experimenting with different solutions. It would use machine learning algorithms to analyze vast data sets of code, identifying best practices, and incorporating them into its own code base. Imagine a world where software updates are no longer a manual process, but a seamless evolution. Self-evolve could automatically identify bugs, patch security vulnerabilities, and even add new features based on user feedback and usage patterns. This would free up developers to focus on higher-level tasks, such as designing innovative user experiences, exploring new technologies, and pushing the boundaries of what's possible with software. Self-evolve would handle the tedious, repetitive tasks, ensuring that the codebase remains clean, efficient, and up-to-date. Of course, the idea of a language that can code itself raises some profound questions about control and ethics. How do we ensure that self-evolve remains aligned with our goals and values? How do we prevent unintended consequences from its actions? These are challenges that we'd need to address carefully, but the potential benefits of self-evolve are simply too great to ignore. It could unlock a new era of software development, where the line between human programmer and intelligent machine becomes increasingly blurred. These languages may not exist yet, but the possibilities they represent are truly inspiring. Thought code, Omni-Optimize, Babel code, Bug Shield, Self-Evolve. These names might sound like something out of a science fiction novel, but they embody the spirit of innovation that drives the tech industry forward. Who knows? Maybe one day, we'll see these ideas come to life and change the world as we know it. Maybe we'll be coding with our minds, breaking down language barriers, or watching our software evolve before our very eyes. Thanks for watching. Don't forget to like, comment, and subscribe for more exciting content. Let us know in the comments which of these futuristic programming languages you'd be most excited to use and what you would create with them.